In this problem, our assignment is to find V0 using loop analysis. And we're going to use a problem-solving strategy for loop analysis. If we look at that, let's see, it's determine the number of independent loops. There are 3 independent loops, and when we assign loop currents, we assign them such that only one current passes through a current source. So if you look, we have a current source here. And we'll do is I'm going to assign the following loop current. I'm going to call this one I1. I'm going to assign this one to be I2, and I'm going to select it where it's the only loop current that flows through the 2 milliamp source. And then here's loop current I3. So we have 3 loop currents. I1, I2, and I3. So we're going to need 3 equations. Okay, now one of our equations is very simple. It's a constraint equation. So now when we have current sources in loop analysis, we get a constraint equation. And that constraint equation is pretty simple. It's I2 equal to 2 milliamps. So here's one of our equations. Okay, now we're going to want to apply KVL to the other 2 loops to get our remaining 2 equations. So let's do for loop 1, which is the outside loop. So for loop number 1, we'll start here. We'll have 2KI1. Okay, there's a drop across this resistor. Then we'll have 3KI1, which is a drop here. For this element, we'll have 4K times I1 plus I2, because the current flowing in this direction, that resistor, is I1 plus I2. Then we'll have minus 12 plus 6K times I1 plus I3. Okay, so now the current flowing down through this resistor is I1 plus I3. We'll come back around. That's minus 10, and that's equal to 0. Okay, now collecting terms, we'll get 15K I1 plus 4K I2 plus 6K I3 is equal to 22. Okay, there's our second equation. And then we've got one more equation, and that's from applying KVL around loop 3. So again, just to remind us about our current assignments. Now for loop number 3, okay, we have, for instance, for this resistor, we have 3K I3 plus 6K times I3 minus I2. As you go around, that's a drop here. For this resistor, we have 6K times I1 plus I3 minus 8 equal to 0. Collecting terms, we have 6K I1 minus 6K I2 plus 15K I3 equal to 8. Okay, so there's our third equation. Okay, and if we look back at our first two equations, we can see that one of them was that constraint equation. And then the second one was for loop number 1. The third one was for loop number 3. Now to simplify the data entry in the MATLAB, I'm going to substitute the constraint equation into equations 2 and 3. So now we'll substitute that into equations 2 and 3. And when we do that, what that will make those two equations become, okay, so if we make that substitution, then one of the equations becomes 15k I1 plus 6k I3 equals a 14. And then making that same substitution into the third equation, we'll get 6k I1 plus 15k I3 equal to 20. So for entry into MATLAB, so all I did was reduce the amount of data we have to enter into MATLAB. Don't have to do that. Okay. So now if we enter this into MATLAB and solve, we'll get I1 is equal to 0.476 milliamps. I3 is equal to 1.143 milliamps. And if we look back at our circuit, we can see that V0 now is 6k I1 plus I3. So V0 is 6k times I1 plus I3. And it turns out to be 9.714 volts.